everybody, today we're going to be talking about graphing, we're going to talk about graphing linear inequalities. So we're going to go ahead and start with some vocab. A linear inequality is basically an inequality written in two variables. So the two variables you normally see are x and y, and that's what we're going to be seeing with the linear inequalities we're talking about. So it's very, very similar to our linear equations that we have to graph. Solutions to linear inequalities are going to be ordered pairs that make the inequality true. Okay, so you're just looking for an x and y that would work and make the whole thing true. That's all we're looking for. And the best way to find an x and y is to use an ordered pair. So graphing linear inequalities is very similar to graphing equations. However, because y can now be equal to or not equal to, because we're talking about an inequality, we're going to use a solid line or a dashed line to represent the solutions on the graph. So because that happens, we have to make that known on the picture that we draw for it. So solid line would be if it was equal to y, and a dashed line would be if it was not equal to y. And also because y can be either greater than or less than, we're going to use shading either above the line or below the line to represent the solutions on the graph. Okay, and it'll make a lot more sense once we actually do one. So here's a little graphic organizer to help you remember. For a solid line, our y has to be less than or equal to or greater than or equal to. For a dashed line, it would be less than or just greater than. Okay? And for shading above, we have to either be greater than or equal to or just greater than. Shading below, less than or equal to or less than. Okay? So there's 4 steps on how to do this, and they're actually really easy steps. So number 1, we just solve. Let's malfunction. It's so sad. Alright, let's try that. Maybe. Ah, there we go. Oh, it went away. There we go. Number 1, we solve for y to make it look like y equals mx plus b. And it looks like this might go away. Okay. So, give you a second to go ahead, pause the video because it's going to go away after I click somewhere else. But if you need more time to write this, I don't know why it's going away. Number 2, I really hate computers sometimes. There we go. Okay. We graph the line using our b, which is our y-intercept, and our m, which is our slope. So we just graph it like a normal line. Okay? Alright, again, pause it if you need more time to write this stuff down, because the computer hates me a lot today. Okay. Third thing is, we just ask ourselves, is it, not shaded, is it going to be solid? Solid. Okay. Solid or dashed. Based on the inequality sign that we have. Oh my god. Right? So we just figured that out. And then our fourth thing is just to determine if we shade above or below based on the inequality sign we have. Okay? And that can go away now. And then don't forget about $40. You're going to need to know that again. If it's a horizontal line, it has 0 slope and it's a y equals equation. If it's a vertical line, it has an undefined slope and has an x equals equation. Okay? Okay. Let's see if it'll work. Okay, so I forgot to add vocab to your notes page, and I'm sorry, but please try to add these vocab words onto your page somewhere, because they are kind of important. A half plane is part of the coordinate plane that is shaded, so once we actually do shade it, the half plane is the half that we shade. Okay? The boundary line, wow, I can't write. The boundary line is the line that separates the shaded from the unshaded. So that's going to be your y equals mx plus b line that you plotted. And a closed half plane is when we are including the boundary line as all of our solutions. So, by the way, when we shade that, the shading is to show all the possible solutions that would work for the inequality. So if we have a solid line, we are including all those points on that line to be solutions. So that's why it would be closed, because we're actually, it's basically closed, think of it like a fence. Okay, and then an open half plane does not include the line of solutions. So that would be like a dashed line, meaning all the points on that line are not solutions, because y can't equal them. Okay? Alright, so example 1, we're going to graph this. So the very first thing we're going to do is get y by itself. So we have 2x minus 3y is less than 12. We go ahead and subtract 2x from both sides. Negative 3y is less than negative 2x plus 12 now. Now we go ahead and divide everything by negative 3. Because we are dividing by negative, we are going to have to flip this sign, so keep that in mind. So now we have y is greater than or equal to 2/3 x minus 4. So you can't really determine what kind of line or shading until you're done and you get y by itself. Okay? So, now that we have y is greater than or equal to 2/3 x minus 4, we are going to go ahead and graph that line. So we plot the point at negative 4. Oh, well, the line. We don't want to plot. But anyway, so we plot the point there, and then we go up 2 and over 3 for our next point. We draw a line through it. It's a dashed line because I am only greater than. I'm not actually including the stuff there. So, and then I'm going to go ahead and highlight it. I gotta make it small now. I have to shade above because it's greater than. So that means all this stuff above the line, all these ordered pairs above the line, actually are our solutions to our inequality. And that's the only way we're going to be able to show all the solutions here. The only other kind of question that you could be asked about this is maybe they give you a point and you have to check if it's a solution. So to check if it's a solution, all you have to do is plug it back into the original. So here we can check our answer and make sure it's true by picking a point in the order in the shaded region, so like 0, 0. Plug it in here. 2 times 0 is 2. Negative 3 times 0 is 0, which gives you that whole side equals 0. 0 is in fact less than 12, so it works. Okay? Now you're going to go ahead and try to graph one on your own. So graph 2y is greater than or equal to 3x minus 4. Pause the video. When you come back, I'll have the answer for you. Okay, so when you did this, you should have solved for y first, and then from there you can graph the line. So this is what it should look like, other than the messy part. But you should have gotten y is greater than or equal to 3 halves x minus 2, and that's the line that you would graph for. It's going to be solid, and you're going to shade above. Solid because you're equal to. Okay? Alright. Now we're going to go ahead and have a graph, and we have to write the equation. So this is a little bit easier because all you have to do is write the slope-intercept form. And all you need for that is the slope, the y-intercept, and then you just need to pay attention to the line, if it's solid or dashed, and where it's shaded. So this one, we're going to look for the y-intercept first. So here's the y-intercept at 2. Oops, right there. Then I calculate the slope, so it looks like I'm going up 1 and over 2, so 1/2. This thing is shaded above, which means it's going to be greater than, but it's dashed, which means it's not equal to. So that means I'm writing out y is greater than 1/2 x plus 2. It's a lot easier, I think. It's a lot less work. Okay? So now you're going to try this one on your own. Shaded below, it's solid, all that fun stuff. So figure that out, pause the video. When you come back, I will have an answer for you. Okay, so you should have gotten y is less than or equal to negative 1/2 x minus 1. Okay? Alright, and here we go. I can go back to the big screen. No, I can't. No, I can't. Alright, so here's the last example. It's a special case one. We have to graph x is less than negative 2. So this is where $40 is going to help you. If this was an equal sign, it would just be x is less than negative 2. That's basically what you're graphing. So you're graphing a vertical line through negative 2, and because it's less than or equal to, or not equal to, because it's not equal to, you're doing it dashed. Okay? So you do a dashed line through negative 2. Now you have to figure out where to shade it. There's no above or below, okay, on the vertical line. So if you pay close attention to it, though, it says x is less than negative 2. Well, where are all the x's less than negative 2? On this side. So that's what I'm going to shade right here, is this part. Okay? So we shade this, and that's all we have to do. Okay? So now on your own, you're going to try the special case of y is greater than 0, which is a little bit easier because y will create a certain kind of line, and there definitely will be an above and below. Okay? So go ahead and try that one on your own. When you come back, I'll have the answer for you. Okay, so y is greater than 0 means it's a horizontal line going through when y is 0 on the x-axis. Okay? and then it's greater than, so that means you shade above in a very messy fashion. So that's it. So if you have any questions, please write them down, and I'll be happy to answer them next class. Other than that, I'll see you later. Bye!